In the vast, silent expanse of space, propulsion is everything. Our current methods, while impressive, are fundamentally limited. They rely on expelling mass, a principle as old as rocketry itself. Whether it is the controlled chemical explosions of a Saturn V, or the gentle push of ions from a modern probe, we must throw something behind us to move forward. This necessity dictates the very nature of space exploration. It means our journeys are constrained by the amount of fuel we can carry. Every kilogram of propellant is a kilogram we cannot dedicate to scientific instruments, life support, or crew. This limitation defines mission durations, destinations, and the grand scope of our cosmic ambitions. It is the fundamental bottleneck we have been trying to widen for over a century. But what if there was another way? Imagine a spacecraft that required no propellant at all. Picture a drive that could generate thrust seemingly from nothing, pushing against the fabric of space-time itself. This is the radical, almost mythical concept of the EM drive, or electromagnetic drive. It proposes to convert electrical power directly into thrust without expelling any form of mass. A propellantless drive would shatter these chains. Suddenly, the payload fraction could be enormous. Spacecraft could be designed for their mission, not just for carrying their own fuel supply. Missions to Mars, currently a grueling 6 to 9 month journey one way, could be shortened dramatically. Some projections for a functional EM drive suggested transit times of just a few months, or even weeks. Satellites in Earth orbit could maintain their position indefinitely without needing to be deorbited or refueled, extending their operational lifespans from years to decades. A trip to the outer planets like Jupiter or Saturn could become a matter of months instead of many years. Probes could be sent to the Kuiper Belt and the Oort cloud, the mysterious outer frontiers of our solar system, with relative ease. The dream of interstellar travel, currently a fantasy reserved for multi-generational world ships or hibernating crews, would inch closer to reality. A craft powered by a nuclear reactor and an EM drive could, in theory, accelerate continuously. It could reach a significant fraction of the speed of light within a human lifetime, making a journey to our nearest stellar neighbor, Proxima Centauri, a conceivable project rather than a distant dream. The story of the EM drive does not begin in the gleaming laboratories of a major space agency. It starts, as many radical ideas do, on the fringes. The concept was first proposed in the early 2000s by a British aerospace engineer named Roger Scheuer. Scheuer claimed to have invented a resonant cavity that, when fed with microwaves, produced thrust. For years, his work was largely dismissed by the mainstream scientific community. The turning point came when whispers of the concept reached a very different group of researchers. In China, a team led by Professor Yang Huan at Northwestern Polytechnical University in Xi'an began their own investigations. Their involvement would catapult the EM drive from the depths of scientific obscurity into the full glare of the international spotlight. At the Johnson Space Center, a small forward-thinking team known as the Advanced Propulsion Physics Laboratory, or EagleWorks, decided to take a look. When news broke that NASA, the world's most famous and respected space agency, was testing an impossible space drive, the story exploded. It became a global phenomenon. Major news outlets, science magazines, and countless YouTube channels ran features on this seemingly physics-defying device. The public was captivated by the narrative. So, what exactly is this device that has caused so much commotion? At its heart, the EM drive is surprisingly simple in its construction. Instead, it is essentially a sealed, cone-shaped metal cavity, often made of copper, that is closed at both ends. The only external input required is electrical power. This power is used to generate microwaves, the same type of electromagnetic radiation used in your kitchen microwave oven, just at a specific frequency and power level. To understand why the EM drive is so controversial, we need to talk about a law of physics that is as fundamental as gravity. This is the principle of the conservation of momentum. The EM drive, as described, appears to break this sacred rule. It is a closed system. The copper cone is sealed, and the microwaves are trapped inside. Nothing is expelled, yet it is claimed to produce a net thrust. This is a scientific heresy of the highest order, a claim so extraordinary that it demands the most extraordinary evidence. For physicists and engineers, this is not just a minor puzzle. It is a direct challenge to the bedrock of classical mechanics. This is the central conflict, the immovable object meeting the unstoppable force of a revolutionary claim. This is why the scientific community reacted with such profound skepticism. The story of NASA's involvement with the EM drive begins not with a grand, agency-wide directive, but in a small, specialized laboratory at the Johnson Space Center in Houston, Texas. Leading the team was a passionate and articulate engineer named Dr. Harold Sonny White. They constructed their own versions of the EM drive, based on the designs of both Roger Scheuer and Guido Feta, an American inventor who had developed a similar device called the Canny drive. In the summer of 2014, the first results from the EagleWorks lab began to leak out. Sonny White and his team reported that they had indeed measured a net thrust from their test articles. They conducted the tests in a hard vacuum to eliminate any possibility of thermal air currents being the cause of the measured force. This was a significant improvement on some earlier experiments. In November 2016, that moment arrived. The paper, titled Measurement of Impulsive Thrust from a Closed Radiofrequency Cavity in Vacuum, was published in the American Institute of Aeronautics and Astronautics Journal of Propulsion and Power. The publication of the paper unleashed a firestorm of discussion and controversy. On one hand, supporters hailed it as the ultimate proof. On the other hand, many physicists were deeply critical. In the wake of the 2016 paper, the scientific community did exactly what it's supposed to do. It picked the results apart. The central focus of the criticism wasn't really about accusing the EagleWorks team of incompetence, but rather on just how immensely difficult their task was. One of the most compelling critiques actually came from a group of physicists in Germany. Among the many replication attempts, the work led by Professor Martin Tajmar and his team at the Dresden University of Technology really stands out. The German team built a state-of-the-art torsion pendulum, but with several key improvements. Their setup was designed to isolate the components and see if heating the power cables alone, for example, could produce a force. In 2018 and again in 2021 with more refined results, they published their findings. The Dresden team reported that they could reproduce the thrust signals seen in the NASA experiments. However, they also showed that these forces were not coming from the EM drive cavity itself. The Dresden results were widely seen by the physics community as the most definitive assessment of the EM drive to date. For most scientists, this was the final nail in the coffin for the EM drive. The scientific consensus is now firm and clear. The EM drive, in the form proposed and tested, does not work. The story of the EM drive is therefore not the story of a revolutionary breakthrough that overturned a century of established science. Beyond the formal world of academic laboratories and peer-reviewed papers, the EM drive continues to thrive in a different ecosystem, the Internet. For a dedicated community of hobbyists, citizen scientists, and engineers, the EM drive is not a closed case. Even as the scientific community moved on, the original inventor, Roger Scheuer, did not concede defeat. In response to the criticism and the mounting evidence against his original design, Scheuer announced that he was working on a second-generation EM drive. While the EM drive itself has been relegated to the annals of debunked science, we should not be too quick to dismiss the spirit of inquiry that propelled it into the spotlight. The entire episode is a testament to the enduring and essential power of asking what if. The quest for our future in space continues, made wiser and more robust by the lessons learned from this remarkable saga. The next true breakthrough in propulsion physics might be just around the corner, waiting for another curious mind to ask, what if?